The universe has secrets. For centuries we've tried to uncover them, gazing up with wonder, then with telescopes, each new tool bringing us closer to understanding our place in the cosmos. Today we have a new eye, the James Webb Space Telescope. It sees in infrared, revealing what's hidden behind cosmic dust, star nurseries, distant galaxies, the unseen made visible. Webb isn't just Hubble's successor, it's a time machine. Because light travels at a finite speed, looking far means looking back. Webb can see the first stars and galaxies after the Big Bang. But Webb also looks at endings, the ghostly remnants of dying stars. These observations are crucial to understanding the cosmic story, a cycle of birth, life, and rebirth. One of Webb's most stunning achievements is its view of the planetary nebula NGC 6072, a celestial ghost, the final breath of a star like our Sun. Before Webb we saw only fuzzy hints. Now, intricate structures and delicate filaments are revealed, patterns that were hidden from us. This isn't just a pretty picture, it's a dataset, a puzzle box of clues about the final chapters of a star's life, a story that will one day be our Sun's. Webb's images are a testament to human curiosity and ingenuity, reminding us the universe is more complex and beautiful than we imagined. Each discovery, from faint galaxies to dying stars, adds to the grand mosaic of the cosmos. We are living in a golden age of astronomy, where the universe is opening up in ways once thought impossible. The journey has just begun, and Webb is our guide into the unknown. The wonders it promises are only beginning to unfold. Let's journey to the southern constellation of Scorpius, 8,000 light-years away, to NGC 6072. The light we see from this nebula began its journey when humans first farmed the land, a distant echo from a dying star. Despite the name, a planetary nebula has nothing to do with planets. Early astronomers thought these glowing clouds looked like planets through their telescopes. NGC 6072 is a glimpse into our solar system's future. In 5 billion years, our Sun will become a red giant, shed its outer layers, and create a nebula like this. At its center is a white dwarf, the hot, dense core left behind illuminating the expanding gas clouds. What makes NGC 6072 fascinating is its complexity. Not a simple bubble, but a tapestry of filaments, knots, and sweeping outflows. These features tell a story of a chaotic, violent end shaped by powerful forces we're only now beginning to understand thanks to Webb's sharp vision. Studying NGC 6072 is like stellar archaeology, sifting through the ruins of a dead star to piece together its life and death. Each element in the nebula, from hydrogen to carbon and oxygen, was forged inside the star over billions of years. When the star died, it cast these elements into the cosmos, enriching the universe. These observations link the life cycle of stars to the chemical enrichment of the universe. This process is essential for forming new stars, planets, and perhaps new life. Webb's view of NGC 6072 is a direct look at the cosmic recycling that shapes everything we know. The nebula is both a stellar graveyard and a birthplace for the next generation of stars. When Webb turned to NGC 6072, it saw extraordinary detail, fine filaments, dense knots, and powerful outflows of gas. These structures are hard to explain with just one dying star. Astronomers now believe there are two stars at the heart of NGC 6072. As the primary star became a red giant, its companion's gravity stirred up the material, creating a swirling disk and channeling gas into focused jets. This two-star model explains the nebula's bipolar shape. The companion star acts as a cosmic sculptor. Webb's observations support this. Chemical signatures and temperature variations match what we'd expect from a binary system. The companion may be hidden, but its influence is clear, like footprints in the sand. By studying these effects, we can infer the presence and properties of the hidden star. Webb's ability to peer through dust may one day reveal this elusive companion directly. The mystery at the heart of NGC 6072 is closer than ever to being solved. Webb's image of NGC 6072 reveals faint concentric rings, ripples expanding from the central star. These regular rings suggest a repeating cyclical process, likely caused by a companion star in orbit. As the stars orbit, the companion periodically disturbs the red giant's atmosphere, creating density ripples in the outflowing gas. Over thousands of years, these ripples become visible as rings, snapshots of the star's mass loss history. By measuring the rings, astronomers can estimate the binary system's orbital period, like reading tree rings for history. These cosmic rings are a fossil record of the dynamic interactions that shape the nebula. Webb's precision opens a new window into the hidden lives of stars. Planetary nebulae are more than cosmic butterflies. They're a crucial, brief phase in a star's life, including our sun's. Studying them is like looking into our own future. In 5 billion years, our sun will shed its layers and form a nebula. These nebulae are cosmic laboratories, with extreme conditions impossible to replicate on Earth. By analyzing their light, astronomers determine their chemical makeup, elements forged inside stars like carbon and oxygen, the building blocks of life. The variety of shapes, from simple spheres to intricate forms, is a puzzle. Binary star interactions are likely the key. Webb's power lets us test this idea, building a model of how stars die. Each nebula is a piece of the puzzle, helping us understand the final stages of stellar evolution. The study of planetary nebulae connects us to the life cycles of stars and the origins of the elements in our bodies. Webb is revealing the beauty and complexity of these cosmic transitions. The death of a star is not an end, it's a beginning. Stars like the one that formed NGC 6072 are nuclear furnaces, forging elements essential for life. When a star dies, it seeds space with these elements, carbon, oxygen, nitrogen, enriching the galaxy. This process, called chemical enrichment, is the foundation for new stars and planets. The gas from NGC 6072 will mix with interstellar clouds, becoming the raw material for future generations. Gravity will pull this enriched gas together, forming new stars and planets with richer chemistry. Each new planet has access to the building blocks of life, thanks to this cosmic recycling. When we look at NGC 6072, we see not just a graveyard but a garden being seeded. The atoms in its filaments will one day be part of new worlds, and perhaps, new life. The cosmos is a cycle of death and rebirth, written across the stars. Webb doesn't just study nearby nebulae, it looks back to the universe's beginnings. Astronomers pointed Webb at the Hubble Ultra Deep Field, a tiny patch of sky famously imaged by Hubble. Hubble revealed about 10,000 galaxies, some from when the universe was less than 1 billion years old. But Hubble's view is limited to visible and ultraviolet light, missing much of the ancient infrared universe. Webb was built to capture this faint, stretched light. Its infrared vision reveals new details and objects, pushing deeper into cosmic history. Webb sees through dust, revealing stars forming in distant galaxies and detecting galaxies invisible to Hubble. The number of known objects in this patch of sky is climbing, and Webb's clarity is transforming a beautiful picture into a three-dimensional map of the early universe. Webb's spectroscopy measures distances, compositions, and conditions in these ancient galaxies. The ultra-deep field is now a richer, more detailed window into our cosmic origins. Webb's new image of the ultra-deep field is a treasure trove. Where Hubble saw 10,000 galaxies, Webb reveals thousands more. Many are small, misshapen galaxies, the building blocks of giants like the Milky Way. Early estimates suggest the universe may contain far more galaxies than we thought, perhaps several times Hubble's count. Webb's sharp images show structure within ancient galaxies, star-forming clumps, proto-spiral arms, and faint galactic nuclei. By comparing galaxies at different distances, we can watch them merge and evolve over billions of years. Webb provides the key frames for this cosmic movie, letting us witness galactic evolution unfold. Each new dot of light is a galaxy, home to billions of stars and planets. Our census of the cosmos is being radically revised, and the grand structure of the universe is coming into focus. Webb is giving us the high-definition story of how galaxies, and perhaps life, emerged. Webb's discoveries, from the ghostly veils of NGC 6072 to the depths of the ultra-deep field, are changing our understanding of the universe. They connect the beginning and end of the cosmic story. Stellar death enriches galaxies, while the first galaxies host stars like those that created NGC 6072. The universe is a place of complex interactions and constant change. The death of a star is a dynamic dance, not a solo act. The early universe was a chaotic time of mergers and growth. These findings fill in our astronomical models and speak to our deepest questions about origins. The elements in our bodies were forged in dying stars. Our galaxy was built from the collision of smaller galaxies. We are, quite literally, children of the cosmos, made of stardust, living in a galaxy built from other galaxies. As Webb continues its mission, it will uncover more surprises. Distant galaxies, alien worlds, and the hidden processes of star and planet formation. Each new image adds to our cosmic story. With Webb as our guide, our view of the universe is clearer than ever.